Afternoon, my dear student. So today I'm going to discuss about the speed time curve for electric traction. Okay. So in my last class I discussed about the last two class actually, 2-3 class I had discussed about the drives. Okay. So power electronics traction drives for normally used for the locomotions. Okay, means for the use for our Indian railways or the traction. Okay, so where we can observe that there are different components for the controlling of the armature voltage. Okay, sometimes controlling of the field current. Okay, so up to base speed, what will be the tentative control? After the base speed, what will be the next controlling methodology? Everything was discussed over there. Okay, now today's session I am going to discuss about the speed time curve for the electric traction. So first, before start that one, so we need to know about it, means why we are going for why we are so much interested on speed time curve. Okay, speed time curvature of the traction. So what is the basic importance on it? So first we need to know about the speed time curve. Means I have already discussed about my very basic classes, what are the different types of tractions. Okay, so types of tractions means you can understand that where we are using that motor coach, okay, for the city ride, for the purpose of city ride, or means intercity, or you may say like that long line, long means long distance. Okay, maybe you know, in technical terminology you can say like that urban, suburban, or the main line transportation. So, okay, so that three categories we are normally means normally bothered for the tractive motions. Okay, so why they are important? Basically, we have to design as an electrical engineer. So we have to design, not like only electrical engineer, as an engineer we have to design the system. Okay, design the efficient system, not the simple one, the efficient system. Okay, so how we have to design the efficient system, how your input efficiently transmit or transform to the output. Okay, so in your retractive drives, if you can see, so input is normally for our normal city ride, you know, like that, for the city, intercity or intracity. Okay, intracity or intercity or the mainline transportation, whatever your electricity, that is 25 kV AC. Okay, that is our main source. Okay, and what is our load? Load is that how much capacity of the train. Okay, if it is public area means if it is EMU, okay, electrical multiple unit, or DMU, initially it is not available, but earlier days it was known as DMU, diesel multiple unit. Okay, so main thing is that how much load you are overcoming and how much distance, okay, you have to travel. Okay, for the intracity, you know that one, for the intracity transportation, if you able to know that the distance between two town, okay, the distance between two places, mean two stoppage, okay, railway stoppage, it is maximum 10 kilometers. Okay, but it is minimum 5 kilometers to in between 10 kilometers. So in between of the time you have to accelerate your train, you have to start your train, means you have to initially overcome the friction, means static friction. Okay, then you have to start your train and you have to accelerate it up to the rated acceleration. Then what happens, how much time is required to acceleration? So that directly depends upon our locomotive inertia. Okay, means how much load is there. Okay, dead load or running load or payload, different types of loads are there, you know, the classifications of the load. In the end of the day, that means current rating, it totally related to the current rating of your system. Okay, so how much current is drawn by the machines? Okay, if such amount of current is there, so how much time to require or pick up that amount of current and with the given time period, that is most important to reach that portion. Okay, then if you see to reaching up to that portion, okay, so you can observe that most of the travel time, okay, you have occupied. Okay, means to reaching the constant value, okay, then you can see you have almost there, means almost you have covered half of the travel period or a travel distance. Okay, then what you need to do, so for the,
Sir, sir, your
sorry,
slides are changing or you haven't changed it?
no,
Because
no,
it
I
is
am
not changing.
changing the slides. Okay, I have just giving the introductions on it. Okay, so now it is changing. Is it changing?
Yes, sir, changing, sir.
Okay, okay. So you can see that how much acceleration you can go. So you can see that time there is no scope for the free running. Okay, so if there is no scope of the free running, then the problem is that so you have to go for deceleration. Okay, or retardation. Directly you have to go for retardation. Again, you know that Newton's law for Newton's first law. Okay, so you can say like that for changing the moment of inertia or the inertia change. Okay, so it will take some time to changing of your current state of inertia to running state of inertia, again running state of inertia to static inertia. So total time period you can see it will overcome for accelerating your system as well as decelerating or retardation of your system. So for the R1 configuration, for the R1 transportation, you can see the curvature is quite different. Okay. Same thing if you go for the suburban. Okay. So suburban, the station length is the distance between two stations is more than of your urban transportation. So where you can have some of the time period for coasting. Okay. Coasting means there is a scope of regenerative braking. Okay. But what happen after coasting, you directly you have to stop that one, stop your machines. Okay, so you have to go for that steady again zero value. Okay, so but in case of mainline transportation, so you will get some time for acceleration, then free running. Okay, then coasting. After that retardation. Okay, so that only can possible for mainline transportation. Basically, the distance I just in my to last class I took some examples for mainline transportation. If you see, it is sometimes 200 kilometer. Okay, so distance between two trains. So definitely all those things also being possible. There may be another sub stages also be there, but that means machines changing the low. That means series parallel configurations of the machine. That for changing of that system, okay, machines having inertia, so it will take some time. So if we don't have such amount of time in our hands for the controlling of the circuit, so we cannot go beyond of that speed. Okay, or beyond that scope. So that's the thing we have to think about it. Okay, so what are the most important features that is written? Typical speed time curve for the mainline service. Okay, so what are the important features are there? The curve drawn between the speed and time. Okay, speed and time means you know that from the speed and time you can understand the travel area. Okay, taking speed in kilometer per hour in the y-axis and the time in the second or minute on the x-axis, known as a speed time curve. Okay, it gives complete information of the motion of the train, distance equal to speed into time. That means I am telling you the traveled area you have to know. Okay, the speed time curve maintain the consist of the acceleration, okay, which are the most important part. First one is the acceleration, second one is your free run or the constant speed run, third one is your coasting, okay, and fourth one is your retardation. So four important point you need to consider for your for the transportations, for the traveling of your locomotives. Okay, so it is your typical structure. Okay, typical speed time curvatures for the mainline service. Okay, so you know that one x-axis what I have told you, so it is your time. Okay, x-axis is your time in second. Okay, and y-axis it is your speed, it is kilometer per hour. Okay, so initially it has started with the zero. Okay, it has started with the zero. Then how much time is required? So rheostatic acceleration means you are increasing the value of armature voltage. Okay, so by changing, how it will possible? You can increase the tap changer. You can use the tap changer for increase the voltage of the armature. Then you can do one thing, you can first pick the rheostat into high position, then gradually you can make it low. So that's why it is telling about your rheostatic acceleration. Okay, so initially 0 to how much time is there, t1 time. Okay, that is rheostatic acceleration. Okay, after that what happens, speed curve running means after rheostatic acceleration, then accelerations is increasing. So you can reach the linear position, then you can see some of the curvature is there. So you can go for that acceleration. Means how to change that acceleration, means you can go for that field control. Okay, if you are going for the field control, that's why some of the curvature is there. Basically it is coming for the non-linear portions. So you know that speed first up to 50 speed. Okay, up to 50 kilometer per hour you can go for rheostatic acceleration, or you say like that armature voltage control. After that up to 100 kilometer, okay, that means twice of your main speed. Okay, up to 100 kilometer you can use that field control. After doing that field control, you can reach the maximum value, okay, of the motor speed. Okay, after that it will take some time. So how much time is there, it is t2. So initially you can see how much value of t1, it is 200 second. Okay, 200 second, it is more or less one third of the 200 second. So how much value is it, 2 third into 200. Okay, means 400 divided by 3. 400 means 3 10s are 30, 3 11s are 33, 3 12s are 36. Okay, 3 4s are 3 into 13 39. Okay, so 13 130, around 130 second. Okay, it is coming around 130 second, so take some time. Okay, 130 second means you can see, you can understand, you can also calculate the time constant. So due to the moment of inertia, due to the inertia, okay, the dead load, the loading of the train as well as the inertia of the entire system, so it will take some time, around 130 second to reach the maximum value. Again it will take another time, so it is more or less 500 second. 500 second means how much minute is it, divided by 60. So you can think like that. So how much minutes is there, so that will take some time to reach the speed curve running. Okay, after that you can think about the free running conditions. Okay, free running condition means you are not able to change anything, it is running up to that value. So again you have to calculate how much distance is pending for the next station. So after getting the calculation, after doing all those calculation, you have to go for that coasting. Coasting means again you can think about the regenerations. Okay, regenerative braking. So due to the regenerative braking means suddenly you can you can say like that, means your input. Okay, input you can just turning off. So that means what happen, your energy is dissipated to the line. Okay, so that amount of value, costing value is there. So again you can see it is linearly dropping that value. So after certain time, so it was t3, so t2 to t3 it is free running, then t3 to t4 you say like that it is coasting. After that you can go for mechanical brake, okay, or vacuum braking. Okay, that braking you can use. So finally you can reach that value 1200. Okay, that is your t5. So total area, how much time is there, so you can get the average speed. Okay, average speed, how to find out the time. Okay, total time into the speed value, t1 into that speed value. Okay, then t2 into this speed value, then t3 into that value. Okay, so sorry, t1, then this portion is t2 minus t1 into this value, then this portion t3 minus t2 into this value, then finally you can average with the total time period. Okay, so you will get the speed value. So finally you can find out the distance, speed into time. Average speed you need to find out. So what are the most important features, so you need to know about it. First point is your accelerations. Okay, second point is your free run or the constant speed run. Okay, third point is your coasting, and finally you can say like that it is your retardation of the braking period. Okay, and okay, so first acceleration means two parts are there in acceleration. First, constant acceleration, okay, or the acceleration during the notching up. Okay, and the speed curve running or the acceleration on the speed curve. So two points are important. Okay, so here acceleration is constant. Okay, so vehicle duty, you know that one. Okay, that acceleration is constant. Then next one you can say like that, V equal to ut plus. Okay, so that formula you know na, So total time period equals to that, s equal to ut plus half at square. Okay, that different formulas are there. Okay, so u plus at, v equal to u plus at, that another thing, s equal to v into t, that different formulas are there. So based on that formula, you can select, you can calculate the value of distance traveled by your locomotive. So first we can think about it, the constant acceleration or on the during of the notching up. Okay, so that notching up period is 0 to t1. Okay, maximum voltage change you can do from this period. The current will be remain constant. Okay, supply voltage will be increased by cutting out the starting resistance. Okay, so drum type control, initially there is drum type control like your tram. Okay, in tram what type of control is that? Drum type control means total thing, your DC portion is there, you are controlling the resistance, input resistance control, so current will be changed, so that is called drum type control. It also happened in the tram. Okay, electric tram, I think you can see the diagram of the tram. Okay, so the tractive effort will remain constant, then acceleration will be constant. Okay, so because it is telling about the constant acceleration up to notching up value, then you can go for the speed curve running or acceleration on the speed curve. So what are the points are there? So speed curve running period, so you need to know about the running period. So it is t1 to t2. Okay, so that period is there. After that the voltage will remain constant, then you can select that approximated constant value of voltage, then current will be decreasing and become constant. Okay, acceleration will be decreased and the finally becomes to the zero. Basically you are maintaining that one, maintaining the conditions. Tractive effort is equal to the resistance to the motion of the train. Okay, that are the most important points for your initially constant acceleration, then acceleration based on your speed type curve. Okay, speed type curve. The next point is your free running of the constant speed. Okay, it's constant speed run. So how much value is it? T2 to T3. Okay, free running period. The train attains the maximum speed. Okay, during this period, the train runs with the constant speed and constant power is drawn. Okay, so that is important. Then costing period. Costing period means the end of the free running period T3 to T4. The power supply is cut and the train is allowed to run under its own momentum. Basically, moment of inertia that I am telling you. So on of your momentum, so costing period, power supply is cut, so it is going up to their moment of inertia, and additional power is feedback to your system. Okay, that means your motor behaves like a generator, so directly it behaves like it's feeding back that additional energy to your bus, to your means catenary or drop that contactor. Through the contactor it is feedback to the input side. Okay, so the speed of train start decreasing on the account of the resistance of the motion of the train. After that you can go for the braking. Okay, so means mechanical braking or magnetic locking braking. Okay, so that is coming later. The speed decrease, the speed during the coasting period is known as the coasting retardation, means it is decelerating. So which duration it is decelerating is coasting period, so it is called coasting retardation. Okay, or coasting deceleration. After that, the retardation of the braking period. Okay, in braking period, at the end of the coasting period, mean T4 to T5. Okay, the breakers are applied to bring the train to rest. Okay, breakers are going to be rest. During this period, the speed decreased rapidly and finally reduced to zero. Okay, so after that, it goes to the zero. How much values are there? So after that, speed is going to be zero. Okay, so then you are using magnetic braking, that I am telling you. So vacuum brakings are there, air brake, vacuum brake, then magnetic locking. Okay, after some duration when train speed is less, then you can go for that magnetic braking, or you know that one, that is dynamic braking, also be known as dynamic braking. Means additional energy now you have to dissipate through the resistance connected across of your motor. Okay, then additional energy it is dissipating through the resistance part. Then the moment of inertia, how do you stop it? So you have to go for magnetic locking. Okay, that shoes are there, wheel shoes are there, that just block. In vacuum, what happen? You just vacuum, you just enable the vacuum block, vacuum brake, and that shoes are directly holding up your wheel. Okay, so what are the typical? So what are the typical curvatures of the urban and suburban. You know the typical speed time curvatures of the urban suburban. So first you know that one, acceleration period is there. Then free running period is not there. Direct coasting means you are turn off the switch. Okay, after that braking. So 3 points are prominent. So speed is maximum speed, you know that up to 60. The 60 to 70. Okay, you know that maximum 70 it is coming. It is your 70 value it is coming. So it is called that suburban service. Suburban service means in this service the distance between the stops is little longer than the urban service. So first they are telling about the suburban. Okay, then we can go for the urban. So suburban means distance between it is coming the longer than the urban service, means it is 1 to 8 kilometer. Okay, that means in mainline less but smaller than the mainline service. Okay, and free running is not possible for the suburban case. The costing is for the comparatively longer period. Okay, acceleration and the retardation required are as high as of the urban service. Okay, so that portion you can know. Okay, it is, you know that how much values are there up to 60 second. Okay, 60 second, more than 60 second. Here if you plot this one, if you project this one in x-axis, you can see it is more or less it is coming 70. Okay, more or less it is coming 70. So 70 second means more than 1 minute. Okay, more than 1 minute is taken to reach the maximum value. Then what happened? 1 minute, then if the travel distance is coming, okay, you can know, you can calculate that speed is 70 speed and time is 1 minute. So you can get that one how much 70 into 5 by 18. Okay, you will get in second. Okay, so 1 minute again multiplied with the 60. So you can get that how much distance is there. Okay, it is, you can calculate in your copy 70 kilometer per hour. Okay, so 70 kilometer for 1 hour. Okay, so 70 kilometer, sorry, in 1 hour means 60 minutes it is travel for 70 kilometer. For 1 minute, how much time is there? So 70 divided by 60, so it is coming 1.167. Okay, 1.167. How much it is in kilometer? I am telling you it is 5 kilometer. It is between 1 kilometer to 8 kilometer. Okay, so that means how much value is it? So almost it is reaching more or less 2 kilometer. Okay, if it is more than 60, so more or less 2 kilometer. So rest of the portion you have to travel. Basically you have to think about the coasting period. So free running due to the moment of inertia, so the up to that portion it will go for that coasting. Okay, that period time, that how much travel area is there, travel distance. Okay, then braking. Okay, that's why the free running options is not possible. Okay, so free running is not possible for suburban service. Then urban service. Okay, urban service you can see in suburban service is distance is more or less up to 8 kilometer. That's why you can reach up to 70 kilometer per hour. The time, say, motor speed 70 kilometer per hour. Here you know that is 1 kilometer to below 5 kilometers. So that's why you are not able to reach up to 60 kilometer. So more or less you are reaching that value up to 55 kilometer. Okay, so 55 kilometers you are traveled around. How much time is there? You can calculate how much time if you project it. So it is more or less 30. Okay, so 30 second. Okay, so 30 second it has normally. Okay, previously I had a mistake. Okay, for 1 minute it was for 1 minute it was reach around 70. So per see, for 1 minute 70 divided by 60. So more or less 1.16. Okay, more or less 1.17. Then how much second is there? Okay, second it is more or less, did that right thing. So it is 60 second plus, that means 1 point something. So it is almost, it is in second, na? So I am calculating in minute. So it is travel, that calculation is okay. So that travel around 2 kilometers. So rest of the thing is the costing. But here you know for the urban service or the city service. So we can think about for the city service how much calculations are there. Okay, so all of you please calculate. So all of you please calculate to your copy. So how much time is required? So it is more or less 0 to, you know, that is more or less 30, more than 30, so 35. Okay, so 35 second. Okay, 35 second means half minute. Okay, for 1 minute how much calculation is there? 60 kilometer for 1 hour. For 1 minute it is, how much value is it? 6 kilometer. Am I right? For for 60 minutes it has traveled 60 kilometer. For 1 minute, so it is 60 by 60 means 1 kilometer. So it is 30 seconds. 30 seconds means half of your 1 minute. So how much value is it? So 6 by 2 means 3 kilometers. So you are telling you, I am telling you the urban service it is below 5 kilometers. So again it has reached up to 3 kilometer. Okay, so rest of the portion it should go for that coasting and finally braking. Okay, so that two portion you need to think about it. Okay, time in second. Okay, so 0, 20, 60, 40, sorry, 0, 20, 40, 60, 80. So in this duration, and you can know that value. In this service, the distance between the stops is comparatively very short. Okay, distance is short, say 1 kilometer. Okay, or so. Okay, the time required for this run is very small. So time required for this is very small. So the acceleration as well as the retardation is required to be high. Okay, so that high average speed and short time run should be obtained. Okay, that's the basic. The free run is not possible due to the line time constraint, and finally the coasting period is also very slow, means also very small. So braking period is more. If you see comparatively for the suburban, so braking period you can see the braking period, the coasting period is more. Here coasting period is less. You can compare with the previous diagram, so you can understand coasting period is less. Okay, so it is your typical speed time characteristics for the urban service. Okay, so what are the important features? Okay, from this table you can understand. So type of service, I am telling you that urban service, suburban service. So acceleration in kilometer per hour. Okay, so per hour per second it is 1.5 to 4 kilometer per hour per second. It is 1.5 to 4 kilometer per hour second, and for mainline service it is zero point 0.6 to zero point 0.8 kilometer per hour per second. Retardations, it is more retardation in case of urban and suburban. More or less it is 3.4 to 3.4. Both of the case. Urban means you say like that example of EMU, and suburban means MEMU. Okay, MEMU means it's big route it is, but it is not like the mainland service. Okay, that is suburban. Okay, maximum speed is 60 for urban, and suburban maximum is 75. Okay, so that's the difference. Distance between the station in urban, that is 1 kilometer to 5 kilometer. It is written only urban is normally 1 kilometer to 5 kilometer, and suburban it is more than, not more than 10 kilometer. Okay, so it is less than 5 kilometer. First one is the less than 5 kilometer, and second one is less than 10 kilometer. Okay, and mainline service, you know the retardations per kilometer per hour, per kilometer per hour per second it is 1.5, and maximum speed in kilometer per hour 110. So that is not more than 10. Okay, so more than 10 kilometer it will maintain that value. So the thing is that what is your crest speed means maximum speed. Okay, that some of the definition you need to know for solving the problem. Okay, from this portion the numerical problem will come. Okay, you have to solve the numerical problem. Okay, so for here you know the maximum speed it is attained by the vehicle during the run known as the crest speed as the maximum speed. Then what is the average speed? So average speed means the distance covered between two stops. Okay, distance covered between two stops divided by the actual time to run or of run is known as the average speed. Okay, so what is the formulation of the average speed? Distance between stop. Okay, distance between stop divided by actual time of run, that is capital T. Okay, that's the formula for the average speed. So between two stops divided by total time period by T. So next point C is your schedule speed. What is your schedule speed? The ratio of distance covered between two stops. The ratio of distance covered between the two stops and the total time of run including the time of stop is known as the schedule speed. So normally how much speed you have calculated for your locomotive of your EMU. So that is called the schedule speed. So what is your schedule speed? So it is schedule speed is the distance between the stops divided by actual time of run plus stop time. So stop time also we counting. So here what is the distance, what is the difference between average speed and the schedule speed. So stop time it is not calculated here in case of average speed. So distance traveled by actual distance, but in schedule speed distance traveled by actual speed plus stop time. Okay, so schedule speed should be the less than of your average speed. Okay, so what is your schedule speed? It should be, you know that schedule speed, the denominator value is more compared to your denominator of your average speed. Definitely that denominator more means that value will be less than your average speed. That is the reason. Okay, why it is schedule speed is less than your average speed, because of the denominator, and numerator is same both of the cases. Okay, difference is large in case of urban and suburban. Okay, negligibly small in case of mainline service. Okay, distance is more in mainline, so that's why it is significantly small in case of mainline service, and in suburban it is maximum 10 km. Okay, that's why it is significant, but actual time of run it is also changed, it is less in case of mainline, sorry, more in case of mainline, but distance is also more, but stop time also been less. Okay, so because the calculations based on the urban suburban totally depends upon how much travel run, how much travel is performed by your locomotive. Okay, so that is important. Okay, so what are the most important factors? Okay, what are the most important factors that for important for the calculation? So first factor is that the factors affecting the schedule speed. Okay, schedule speed means what is the formula of schedule speed? Distance between the stop divided by actual time of run plus stop time. Okay, so the schedule speed is given is given schedule speed of a given is affected by the following factors. So what are the important factors? Effect of the acceleration and the braking retardations. Okay, so acceleration and braking retardation. Okay, for a given run and with the fixed press speed means maximum speed, the increase of the acceleration with the results in the decrease of the actual time of run, therefore increase of the schedule speed. So how would you reduce it? So you can increase, you can make the system more accelerating. Okay, so how is it possible? How would you make it more acceleration? By increasing the accelerations. Okay, means a value you can increase. Okay, acceleration a value you can increase it by field control. Okay, the similarly increase of the braking retardations, the effect of the schedule speed also affected. Okay, so by that what happened? Braking retardation means deceleration time. Okay, variation in the acceleration and the retardation will have more effect on the schedule speed in the case of the shorter distance run in comparison to longer distance of run. Okay, so that you can understand that acceleration and the retardation, variations of the acceleration and retardation will the more effects on the schedule speed. Okay, in the case of shorter distance. Okay, for if the distance is short, so definitely it will be more affected. Okay, because that run time also be less and stop time also been constant throughout the cycle. Okay, throughout the period. Okay, the effect of the maximum speed. For the constant distance run with the fixed acceleration, the retardation of the actual time run will decrease. Therefore, the schedule speed will increase with the increase of the press speed or the maximum speed. Okay. The effect of variation of the press speed or the maximum speed on the schedule speed is considerable in case of the long distance run. Okay, it's also we observe for the long distance run. Effect on the duration of the stop. Effect of the duration of stop. For the given average speed, the schedule will increase the reducing of the duration of the stop. Okay. The variation in duration of stop will affect the schedule speed more in case of the shorter distance run compared to the longer distance run. So that portion is important for the effect of the duration of the stop. So three most important portions. So braking The effect of acceleration and the braking reduction, that is important. Next important thing is that what is your maximum speed, and third one is your duration of the stop. Okay, so you know that distance between the stop, actual speed of run, stop time. So that 3 points are more important, and actual speed of run, again it depends upon your acceleration period, that is mentioned here, acceleration. Okay, that acceleration means constant acceleration, another one speed curve running acceleration. Okay, so two accelerations are there, that's why the speed of the actual time of run, that depends upon your acceleration. More acceleration means time will be less. If time will be less and rest of the thing is same, so speed also be more, inversely proportional. Okay, time is more, runtime is more means it will be less, inversely proportional. Okay, so that kinds of observation you can see different factors. Okay, for controlling of your schedule speed. Okay, so now simplified, we can go for the simplification. Basically, end of the day, we have to solve the numerical problem. Okay, for the solving of the numerical problem, that features of the schedule speed, the features of the speed time curvature is important. Okay, so what will be finally, how it will be look like, which type of shapes, which shapes, how does it look like? So that is important for solving the numerical problem. So first, you know that one, it is given how much, it is look like that, it is suburban, I think so. First one is your suburban type, so acceleration, then retardation, then finally, no sorry, it is for mainline transportation. Okay, it is for mainline. Okay, it is for mainline, I think so. So free running is there, means mainline. Okay, so approximated the trapezoidal speed time curve, approximate trapezoidal speed time curve. So both of the cases you can see. Okay, so convert or replace the typical speed time curve to the simple geometric shape curve is known as the simplified speed time curve. Okay, so what is the motivation of this simplified speed time curve? So you have to convert or replace the typical speed time curve to simple geometric shape curve is known as the simplified speed time curve. From these simplified curves, the relationship between the acceleration, retardation, average speed and the distance can be easily worked out. Okay, so I am telling about you the numerical problem means distance calculation of the distance. You can do calculation of the distance. You can do. Actually, some of the error may be there for the calculations, but that how much percentage of error, that you have to calculate. That you measurement, so you know that calculation of error. So if that error is not so significant, so you can neglect some of the portion. So your main thrust area should be that nearer. You have to design your speed time characteristics should be convert to the nearer geometric shapes, and you can calculate the distance. Not like only distance, acceleration, how much time is required, everything you can calculate. Okay, so trapezoidal curve can be used for mainline service, and the mainline service means your mainline service you can consider it's a trapezoidal shape. That coasting effect is there, then free running effect is there, then coasting effect is there. That's why mainline shape, mainline calculations, mainline service you can consider it's a trapezoidal sense. And quadrilateral say curve you can see for the urban and suburban. Okay, two type of curvature is there. So the urban suburban there is no free running, only retardation. Okay, or coasting. So you can say like that entire thing. That entire portion you can see it is linear. Then rest of the portion for the coasting and finally braking. Okay, that's the way you can realize the speed time curve. Okay, so calculations of the speed time curve for I think today I can complete that portions for the mainline curvature I have discussed. For first case, that mainline curvature, then suburban, then finally urban service or the city service. Then we can realize the shape of the actual shape of the actual speed time curve to the equivalent geometrical equivalent speed time curve. Okay, so here you can calculate the trapezoidal speed time curvatures. Okay, so what is your trapezoidal speed time curvature? So you know it is your speed kilometer per hour, it is given. Okay, so it is your time in second, total time period is your t. Okay, that you can calculate that value of t. So s1 is your travel distance for t1 instant. Okay, so for t1 you can calculate, then s2 you can see your maximum attain speed is vm, and S3 is your finally coasting period. Okay, coasting and retardation. So by time period is T3, and for S2 and S2 the time period is your T2. So first one alpha, what is your alpha? Acceleration in kilometer per hour per second. Beta is your retardation in kilometer per hour per second. That one retardation. Vm is your maximum speed or crest speed. T is your total time of run in second. T is total time of run. Time for acceleration in second, that is T1. T1 equal to, you know that 80, V equal to 80, that I am telling you. P equal to 80 or A means alpha. So Vm, so T1 equal to Vm by alpha. For the regular retardations in second, T3 equal to Vm by beta. Okay, so that considerations are there. For time for the free run condition, T2 equal to T minus T1 plus T3. Okay, so finally you can replace the value of T1 and T3. It is coming T minus Vm by alpha plus Vm by beta. Okay, that is your final relation. Okay, so it is your trapezoidal speed turn curve. So total distance travel. Okay, distance travel during T1 means during acceleration. Distance travel during the free run. Distance travel during the retardation. Okay, so total distance S equal to what is the value? S1 plus S2 plus S3. So three things are there. You can add both of the distance, sorry, among all the distance S1, S2 and S3. So final S you can calculate. So same thing, how do that value? So S1 equal to, that I am telling you, ut plus half at square. So u initially that value is 0. Okay, so that's why it is coming half at square. So you know that value of the value of t means Vm by alpha. Okay, so a t1 square means Vm by alpha, that value is there. Sorry, half a t square means you can calculate the value of alpha. You can replace alpha equal to Vm by T1. So at square will mean Vm by T1 and whole square. So T1 T1 cutting this. Finally, you can get it from the relationship. Okay. So you know that area how it is half base into, sorry I am getting the wrong thing. So that is area. Okay. So area of the triangle. Okay. Area of the triangle means half base into height. Base equal to T1, height equal to how much value is it? It is Vm. Okay, half base into height. Base equal to T1 and height equal to T1 in second. So you can make it in hour. So T1 whole divided by 3600. So it is in your now hour. Vm is as Vm equal to kilometer per hour. No? So Vm equal to kilometer per hour. So that's why that value is there, kilometer per hour. So you need to convert that T1 second into the hour. So you put that T1 equal to Vm by alpha. So finally you will get S1 equal to Vm square by 7200 alpha. So similarly you can put the value of S2, Vm T2 whole divided by 3600. T2 equal to, you can calculate total time period T minus T1 plus T2. T1 value equal to Vm by alpha, T2 value equal to Vm by beta. You can replace them. Finally you will get that expressions. Okay, of S2. Then similarly you can find out the value of S3. Okay, put T3 equal to Vm by beta, S3 equal to Vm square whole divided by 7200 beta. Now you can replace S equal to S1 plus S2 plus S3 and equate the quadratic equations, and you can take a constant k equal to 1 by 2 alpha plus 1 by 2 beta. Okay, finally you have the quadratic equation and you can calculate the value of roots. Okay, so how much value of there, you can calculate the value of roots Vm. Okay, so Vm equal to, by using the Siddha charges formula, so Vm is coming there t by 2k minus root under t square by 4k square minus 3600s whole divided by k. For the positive sign will be much higher value than in possible the practical value. So take for the negative value sign is not negative sign for the calculations. Okay, so you can calculate both of the sense. Okay, so whatever you can think it is coming, but negative speed is not possible. Okay, speed definitely in positive. Okay, so you have to look into that calculations. Okay, so after how much value is there after putting all those root, basically negative speed will breaking in the situation it may occur. Okay, so that's the way you have to calculate the thing, and finally you can get that results. Then we can, it is for the trapezoidal. Now we can go for that quadrilateral. Okay, so calculations by the quadrilateral speed time curve. Okay, quadrilateral speed time curve means alpha equal to acceleration in the kilometer per hour. So beta c equal to costing of the retardation in kilometer per second. So braking, okay, beta value, beta c means costing. Beta is for costing. Beta equal to braking and regenerations. Okay, or retardations. And v1 is the maximum speed at the end of the accelerations in kilometer per hour. Beta v2 is the maximum speed at the end of coasting. So it is your v1. So what is v1? This point is v1 and this is your v2. So here you can see it is your v2. Okay, so it is your speed kilometer per hour and it is time in second. Total time is t. So t1, t2 and t3. So it is s1, s2 and s3. Three things are there. So for the time of for acceleration, t1 equal to v1 by alpha. For retardation in second, t3 equal to v2 by beta. And for the running condition, t2 equal to v1 minus v2 by beta c. Okay, it is your quadrilateral speed time curve. Okay, so total travel distance, how much value is it? Total travel distance in run in kilometer, it is distance travel during the acceleration plus distance travel during the coasting period, and finally distance travel in the during the braking period. So same process like your previous condition. So s1 s equal to s1 plus s2 plus s3. So now we can replace the value of s1 like your previous formula, okay, for s2 and s3. So you can replace them in the main equations and finally you will get a quadratic equation like your previous formula. So you can finally you can put the value of t1, t3 and you can calculate the value of v2 and v1. If you have the value of v1, so you can easily find out the value of v2 and t1, t2. So you can replace them in the equations and you can equate them to getting the finals value. Okay, if all the parameters, most of the parameters or most of the variables given to you, you can easily calculate the travel area, okay, or travel distance by using the standard formula. At the time of examinations, that numerical problem will be given to solve the analytical problem. So in that case, you have to use those formulas, okay, but you should not use only the final results. You have to do the derivations, okay, stepwise derivations, okay, and based on your derivation, the marks will be given. You cannot use the final formula. Okay, so basically you have to follow the steps of derivations and need to calculate the final results. Okay, so all the steps should be shown, okay, in the exam paper. Okay, if you are saying if you are showing only one step, so definitely proportionate marks will be given. Okay, so before doing anything, so steps should be from your side. The each and every step should be you are confident enough and you have to show to your exam paper. Okay, so I think today I have discussed up to these portions. Okay, in my next portion, next class, I will discuss about the pending portion. So and one announcement is there regarding the last class. Okay, so I just forgotten. I forgotten to told you to tell you to submission of your class note, like your last discussions, basically the DC drives, AC drives, okay, power electronics control DC drives, AC drives. So by this, today is Monday, okay, so by this Thursday, you have to submit this class note, okay, the next class note up to my discussed in my last class, okay, and after completions of this module, it is some module of module 1, okay, after completions of my this module, again you have to submit the entire class note of your speed time curvatures of your electric traction. Okay, so if you have any kind of confusion, you can write me the mail, you can WhatsApp me, so I can give you the suggestions. If you have any confusion, you can ask me, so I can stop my today's session. Okay, so I hope if you have any discussion, doubt, you can put me, you can write in the chat box. Okay, otherwise I will stop my session, today's session. And I expecting the class note you should complete by coming Thursday. Okay, that means on 14th, before 14th night, you have to submit it. Okay, so more question from the chat box. I hope you do not have any kinds of confusion, any
Sir,
kinds of question. Yes.
Sir, I don't have any doubt, but one thing to say, sir, please set a perfect timing for the class, sir. Sir, either it's from 12 to 1 or on the regular time as per the timetable. Mm, that is creating a lot of problem for us, sir.
Okay, so normally what happened, I have fixed it. Okay, today I'm just stop my session, just wait. हाँ सत्य